Section 9.1 Two Proportions. In Chapter 8, we learned how to answer these type of questions. Is mu equals 8? Or is p less than 0.75? In this chapter, we will learn how to answer these questions. Is mu1 equal to mu2? Or is p1 greater than p2? So instead of comparing the perimeters with a number, we are comparing two different perimeters from two different populations. In this section, we will learn how to conduct a hypothesis test of a claim about two population proportions. We also learn how to construct a confidence interval to estimate the difference between two population proportions. P1 stands for population proportion. P hat is sample proportion, which is x1 over n1. N1 is the size of the first sample. Q hat 1 is 1 minus P hat 1. X1 is the number of successes in the first sample. The corresponding notations P1, N1, X2, P hat 2, and Q hat 2 apply to population 2. The pool sample proportion is denoted by P bar, and it combines the two sample proportions into one proportion. P bar equals to the sum of x1 and x2 divided by the sum of n1 and n2. Q bar is 1 minus P bar. Example 1. In a large clinical trial, 392,857 children were randomly assigned to two groups. The treatment group consists of 198,005 children given a vaccine for a certain disease, and 39 of those children developed the disease. The other 194,852 children were given a placebo, and 149 of those children developed the disease. Consider the vaccine treatment group to be the first sample. Identify the values of N1, P hat 1, Q hat 1, N2, P hat 2, Q hat 2, P bar, and Q bar. I have two different groups. The first group is the treatment group with sample size of 198,005 and X is 39. The second group is the placebo group with N is 194,852 and X is 149. I am organizing these information in a table. The left part is my first group and the right part is my second group. I am going to work on the group 1 first. I need my P hat 1, which is x1 over n1, 39 over 198,005. So I get 1.969647231 times 10 to the negative 4. This is a scientific notation. To convert this into a decimal notation, I will move this decimal point to the left 4 places because this is negative 4. If there is an instruction on how to round the number, please follow the instruction. In this one, I am going to round it to 3 significant figures. So my P hat 1 is 0.000197. Q hat 1 is 1 minus P hat 1, which is 1 minus 0.000197, and I get 0.999803. For P hat 2, I'll take x2 divided by n2, which is 149 over 194 852. And I got 7.646829388 times 10 to the negative 4. I am going to move the decimal point to the left 4 places. And I round this to 3 significant figures. P hat 2 is 0.000765. To find Q hat 2, I take 1 minus P hat 2. And I got 0.999235. P bar equals to x1 plus x2 over n1 plus n2, which is 39 plus 149 over 198005 plus 194852, which is 188 over 392857. My P bar is 4.785456 times 10 to the negative 4. To convert this into decimal notation, I move the decimal point to the left 4 places. And I round it to 3 significant figures. Q bar is 1 minus P bar, and that is 0.99521. Requirement for conducting the hypothesis test for 2 proportions. First, the sample proportions are from 2 simple random samples. Second, the 2 samples are independent. Third, for each of the 2 samples, there are at least 5 successes and 5 failures. Equivalent method. When testing a claim about 2 population proportions, the p-value method and the critical value method are equivalent. The confidence interval method is not equivalent to the p-value method or the critical value method. Example 2. Rhinoviruses typically cause common colds. In a test of effectiveness of echinacea, 37 of 43 subjects treated with echinacea developed rhinovirus infections. In a placebo group, 76 of the 92 subjects developed rhinovirus infections. Use a 0.05 significance level to test the claim that echinacea has an effect on rhinovirus infection. I have 2 different groups. One is the treatment group with N is 43 and X is 37. The other one is the placebo group with N is 92 and X is 76. Question A. Test the claim using a hypothesis test. Question B. Test the claim using the confidence interval. First, I need my original claim. Use a 0.05 significance level to test the claim that echinacea has an effect on rhinovirus infection. So in this problem, we want to test to see if the group that has treatment, the proportion of people who got infection is different from the group that they don't get treatment. So I want to check to see if P1 is different from P2. Step 2. If the original claim is false, then what happened? If P1 is not equal to P2 is false, that means P1 is equal to P2. 3. I am going to write my hypothesis. I need my HO and HA. From the 2 statements that I got from the first 2 steps, the one that contains the inequality is going to be my HA, P1 not equal to P2. My HO will be the statement contains the equality. There will be a different way to write your HO and HA. Now, instead of saying P1 equals to P2, if I subtract P2 from both sides, if I bring this over to the left side, this is also equivalent to P1 minus P2 equals to 0. And if I bring the P2 to the left side, this is equivalent to P1 minus P2 not equal to 0. These two are both correct. You can use this or this. Doesn't matter. My HA contains not equal to, so this is a two-tailed test. Significance level is alpha 0.05. For test statistic and p-value, I will use StatCrunch to find these two numbers. Stat, proportion stats, to sample, summary. This is where I put the information from my sample 1, and this is where I put the information from my sample 2. X1 is 37. N1 is 43. X2, 76. N2, 92. Select the hypothesis test for P1 minus P2. HO, P1 minus P2 equals 0. HA, P1 minus P2 not equal 0. Compute. This is my test statistic, and this is my p-value. Z equals to 0.5038796. And I will round this to 2 decimal places. P-value is 0.6143, and I round this to 3 significance figures, 0.614. To make my decision, I will compare my p-value with my alpha. So since p-value is greater than alpha, I will not reject my HO. I failed to reject my HO. My HO says P1 equals P2, and I did not reject it. That means I believe that this is correct. And that means that I don't think this is correct. And this is my original claim. So I don't think the original claim is correct. That means I don't think that echinacea has an effect on rhinovirus infections. Question B, test the claim by using the confidence interval. First, I need to construct my confidence interval. In order to do this, I need my confidence level. And in order to have my confidence level, I need to have my alpha. This test is a two-tailed test. Since this is two-tailed test, my alpha is going to split into 2. This is half of alpha, and this is another half. This piece is 0.025. This piece is 0.025. So if you take this little piece, add to this little piece, add to the rest, it should be 1. So this add to this is 0.05. Add to this should be 1. So this should be 0.95. The formula to find the confidence level in a two-tail test is 1 minus alpha. If you have a two-tail test and you have an alpha, in order to find a confidence level, you take 1 minus alpha. This confidence interval is the confidence interval for the difference between P1 and P2. And I will use StatCrunch to do this. Stat, proportion stats, to sample with summary. X1 37, N1 43, X2 76, N2 92. Instead of choosing the hypothesis test, we are going to choose the confidence interval, and my level is 95%. This is my lower limit, and this is my upper limit. I will round this to 3 significant figures. So if I take P1 minus P2, the difference will be in between these two numbers, and I'm about 95% confident. So P1 minus P2 will be somewhere between negative 0.949 to 0.164. How do I use this confidence interval to make my decision? So if I go up here to my HO, say P1 minus P2 equals 0. And this is P1 minus P2 not equal to 0. So this is the confidence interval for P1 minus P2. This goes from negative to positive. That means 0 is in between. I am about 95% confidence that P1 minus P2 is in here. And if you look at HO, it says P1 minus P2 equals 0. 0 is included in this interval because it goes from negative to positive. That means I am 95% confidence that my HO is true, which means I will not reject my HO because my confidence interval contains 0. And the conclusion should be similar. Example 3. In a random sample of 360 women, 65% favor stricter gun control laws. In a random sample of 220 men, 60% favor stricter gun control laws. Tester claimed that the proportion of women favoring stricter gun control is higher than the proportion of men favoring stricter gun control. Use the significance level of 0.05. I have 2 samples. One is women with N is 360 and P hat is 65%. The second sample is men with N is 220 and P hat is 60%. I will call the group of women is the group 1 and men is group 2. N1 is 360, P hat 1 is 0.65, N2 is 220, P hat 2 is 0.6. I need my X1 and X2. X1 is P hat 1 times N1, which is 234. X2 is P hat 2 times N2, which is 132. Question A. Test the claim using the hypothesis test. Question B. Test the claim using the confidence interval. These are the 8 steps that we need in order to do the hypothesis test. The first step is the original claim. Test the claim that the proportion of women favoring stricter gun control is higher than the proportion of men, which means I want to see if P1 is greater than P2. If P1 greater than P2 is false, then P1 is less than or equal to P2. Between the first two statements, the one with no equal sign is going to be my HA. And HO always contains the equal sign. I can also move the P2 to the left side to have P1 minus P2 equals 0 and P1 minus P2 greater than 0. These two ways of writing HO and HA are equivalent, so it doesn't really matter which way you use. They both are correct. HA contains the greater than, so this is the right tail test. Significance level was given. Alpha equals 0.05. I will use StatCrunch for my test statistics and my p-value. Stat, proportion stats, 2 samples with summary. X1 is 234 and 1 is 360. X2 is 132 and 2 is 220. HO say P1 minus P2 equals 0. HA say P1 minus P2 is greater than 0. Compute. This is my test statistic and this is my p-value. I will round z to 2 decimal places. So I get 1.21. And my p-value is 0.113. To make my decision, I compare the p-value with alpha. Since p-value is greater than alpha, I do not reject HO. My HO says that P1 equals to P2. HA say that P1 is greater than P2. Since I do not reject HO, that means I believe that P1 equals P2. That means I don't believe that P1 is greater than P2. That means I don't think that the proportion of women is higher than the proportion of men. Question B, test the claim using the confidence interval. First, I need my confidence level. I need to use the fact that this is a right tail test and alpha is 0.05. In a right tail test, your alpha is on the right, which means 0.05 is on the right. You don't have any alpha out here. However, your confidence level should be the area in the middle. It should be in the middle. So you have to imagine that there is another part out here that is equivalent to this. So this is 0.05, this is 0.05. They add up to be 0.10. The middle should be 0.9. The formula to find the confidence level when you're working on a right tail test or a left tail test is that you are taking 1 minus 2 times alpha. So if you take 1 minus 2 times 0.05, you should get 0.9. This applies for right tail and left tail tests. To find the confidence interval for P1 minus P2, I will use StatCrunch. To construct the confidence interval, instead of entering the information from the beginning, you can also click on here and choose Edit. Now you have your information in here. All you do is change it to confidence interval and change the level to 90%. Compute. This is my lower limit and this is my upper limit. And I will round it to 3 significant figures. To make my decision, I need to look at my HA. HO says P1 minus P2 equals 0. And this interval is the interval for P1 minus P2. I am about 90% confident that P1 minus P2 should be in between these two numbers, which is from negative to positive, which means 0 is in between. Which means that I am about 90% confident that my HO is true. That means I do not reject HO. And the conclusion for this should be similar to the previous part. Example 4. Among 2,173 passenger cars in a particular region, 237 had only rear license plates. Among 362 commercial trucks, 54 had only rear license plates. A reasonable hypothesis is that owners of passenger cars violate laws requiring front license plates at a lower rate than commercial truck owners. Use a 0.05 significance level to test that hypothesis. I have 2 different groups. One is passenger cars with N is 2,173, X is 237. The second group is the commercial trucks with N is 362 and X is 54. Owners of passenger cars violate laws requiring front license plates at a lower rate than commercial truck. I want to test the claim that my P1 is lower than P2. A. Test the claim using hypothesis test. B. Test the claim using the confidence interval. My original claim is P1 less than P2. If the original claim is false, then P1 is greater than or equal to P2. Between the two statements, the one that does not contain equal sign is my HA. HO always contains equal sign. Or my HO can be P1 minus P2 equals 0, and HA is P1 minus P2 less than 0. This contains less than, so this is a left tail test. Significance level is alpha equals 0.05, and I will use StatCrunch for my test statistics and my p-value. Stat, proportion stats, 2 sample with summary. X1 is 237, N1 is 2173, X2 54, N2 362. And I will change my HA to less than. This is my test statistic and this is my p-value. For the z-score, I'll round it to 2 decimal places, which is negative 2.22. P-value is 0.0133. p-value is less than alpha, I will reject my HO. So HO say P1 equals P2, but I reject it. That means I believe that P1 is less than P2. So what does that mean? It means that I believe that the passenger car violate laws requiring front license plates at lower rate than commercial truck owners. B. Test the claim by using confidence interval. First, I need to determine my confidence level. In order to determine the confidence level, you have to use the fact that this is the left tail and the alpha equals to 0.05. So this is the left tail test. That means alpha is on the left side. However, my confidence level must be the middle part, not the left. It's got to be the middle part. So I need to have an invisible tail on the right, and this is also 0.05. Alpha should be this middle part right here. So 1 minus 0.05, 0.05 make this one 0.90. For a left tail test, if you want to find a confidence level, you're going to take 1 minus 2 alpha. If you remember this rule, you don't have to do the graph every time. And I will use StatCrunch to find my confidence interval. To construct the confidence interval for the same problem, I will just click on here and choose Edit. Now I don't need to enter the information from the beginning. All I do is just change it to confidence interval and change my level. This is my lower limit and this is my upper limit. I will round this to 3 significant figures. This is the interval for P1 minus P2. And I'm about 90% confident about this interval. My HO is P1 minus P2 equals 0. This interval is from negative 0.0728 to negative 0.00740. 0 is not contained in this interval. That means HO is rejected because 0 is not in here. And the conclusion should be similar to the previous part.